let's look at this two-sided hypothesis test for normal data. So this is the Metro ridership for 2020 again. So we have 630,000 riders on average per day up through January of 2020. And then let's say that since then, we sampled 100 different weekdays and we got an average ridership of 175,000 with a standard deviation of 20,000. We already set up our null and alternate hypotheses. So what we're going to do now is calculate our test statistic. And this is exactly the same thing that we used when we were calculating the probabilities on a normal distribution earlier in the semester. So we're going to use z, not z star, which is a critical statistic. It's z is a test statistic, equals, we're going to use x bar minus mu over s over square root of n. And you can find this on the Math 300 equation sheet as well. And now we just plug in our numbers. So we have 175,000 minus 630,000, that's from the null hypothesis, divided by our sample standard deviation of 20, divided by the square root of 100, or sample size. And when we plug this in, we're going to get minus 227.5. So what is this number telling us? Okay. This z statistic says that if we're going to put this on a normal scale, in a normal distribution where we have a mean of 0 and a standard deviation of 1, that our observation is 227 standard deviations below the mean. Now, remember, if you have something that's 2 standard deviations below the mean, let's say right here, and if this is the mean, that the area out here under this curve is only going to be 0.025, because this within 2 standard deviations is going to be 95%, right? Okay, we're 227 standard deviations down, so that's really far out here in the tail. So the area in that tail is going to be super tiny, and that means that the probability of seeing this observation from a distribution with a mean of 630,000 is extremely small. So, and if we calculate that, that's called the p-value. And in this case, the p-value is going to come out to be pretty darn close to 0. So the conclusion that we would draw is that we reject the null, and we conclude that the ridership has changed. Now, one more thing for the two-sided hypothesis test. Let's say that we had come out here and we'd ended up at 2 standard deviations above and below. The p-value, the total probability that it has changed based on our observation, is not just this area here for this tail. We also include the area over here, just because this is the definition of our two-sided test. So when you're doing a two-sided test, you have to double the calculated probability here to get the p-value.